Hello, let me introduce myself. My name is Kawecki, physicist, author of the Supertellic electromagnetic gravitational universe technology theory. It's a 500-page book on modern physics. It's the first book of its kind on faster than light speed space travel. The introduction of this book, and it's in bookstores everywhere, United States and Europe and Canada now. And the interesting part of it is, like I said, it's the first book ever on fast and light speed space travel. If you know anything about physics, faster than light speed space travel is in a kind of like limbo of whether it's possible or not. There are some proofs that say that it is possible. There has been evidence and experiments that show that it's possible. For instance, a clock on Earth under a gravitational field ticks slower than in a non-gravitational field. This is proof from NASA and their experimentations. My book covers 500 pages of research in a 10-year period I called the quantum physics study. It's a study that was done to discover whether or not, with relativity, with what special and general relativity says, whether or not fast and light speed space travel is possible. The evidence after that research is that it is. This discovery is made on the literature and the aberration of Albert Einstein in 1903, who didn't want to follow up on zero-point gravity, zero-point energy, and zero-point gravity, which are about the same thing. Gravity is energy, magnetic energy acting on an object. When you throw an object up on Earth, it comes down. You throw an object up in space, it just keeps on going up and up and up. I think everybody knew this, but nobody ever wrote a theory on it. I have written the first theory on FTL, fast light speed space travel. It corresponds with relativity, the equations in relativity, the mathematics, E equals mc squared. But there's 2 points of views that we have to look at. The one is the gravitational state, as Einstein predicted in his study, and then the non-gravitational state, which is interstellar space, which is my study. I actually call it the other half of relativity, which means that it's what Einstein did not want to look at that time. Like I said, during an experiment, it's called the M&M experiment, the Mitchell and Morley experiment on the speed of light in vacuum. Morley says, well, what about ZPE by Max Planck? Measuring the vacuum is zero-point energy, which is zero-point energy. You have to have zero-point energy to have a vacuum. So there's no magnetic activity. So that there tells you something's different. In a gravitational state, you got magnetic pull. In a non-gravitational state, you have no effects at all. Well, this is what was found. But what Einstein did is based his theory also on light, which is a non-gravitational uh, particle, uh, quantum particle, or quantum particle, or they call it quantum in quantum mechanics. But to any event, he didn't want to study that. He rejected that, telling Morley, Edward Morley, he says, light is constant. The idea here is this is what baffles me, and through science. Even though the light is used for light signals, and the boosting of light would make faster than light signals, it has nothing to do with space travel in a ship. A ship is made of matter. It's not light. It's not a particle of light. Einstein bases his theory on this, but if he went and followed up on what Morley said about zero-point energy in the medium, which is non-gravitational state, he would have discovered that he would have to write another theory. That theory has been written by me. I'm Rod Kawecki, Los Angeles, California. My book is 500 pages. Everything. Einstein's book was only 100 pages when he wrote his page. He wrote 5 papers, single papers, on his achievements in relativity, which were quite important, but he never went into the aspects of interstellar non-gravitational space accelerations and what would happen. Mitchell Alcubierre, which is Alcubierre warp drive, you might know him. He studies in New Mexico. He's a professor at the university there in New Mexico, and he has composed the first theory on warp space. See, Einstein said, okay, Einstein knew that there was no gravity in space, but he said there was warp space. Space is already warped. Okay? And it's warp space that acts on it. In other words, the space itself, the fabric of space, the idea that a planet curves the space where it's at, away from it. He knew that there was some type of effect. But the only thing is, now, in my theory, you take warp space. This is a planet of a certain mass, which is fantastic, great. And then you see in Star Wars and Star Trek, planets as big, or ships as big as planets, which warp space, planets are bits and pieces of a larger singularity, which is the Big Bang, cosmic age. Now, those bits and pieces warp space. Okay, a ship, a spacecraft, 2 miles long, let's say, a million tons. In fact, I think one of those figures are in Einstein's book, one of Einstein's books. But it's very little compared to what a planet weighs. And to that effect, what degree does warp space have on that vessel traveling, acceleration? Well, Einstein never investigated it, but concluded that the speed of light was the same no matter what, which it is, but that's light. Now that's light. It's not mass. A mass ship's acceleration is not the same if you have potential capacity, propulsion energy. Science now is trying to find different energy concepts and types for propulsion. But the fact is that the universe was created in warping space. You take a 2-mile ship and its mass and say that it's confined to the speed of light, where all the planets together warp space